Okay, so the question over here is shortest bridge, and it's a hybrid problem because it uses both traversals, each for the job it is best at. So we are going to use DFS to find and mark all cells of the first island, and then we will use a multi-source BFS, which will start from every cell of that island simultaneously, expanding outward level by level through water until we touch the second island. So the number of levels equals to the water cells crossed, which means like the bridge length. So now I'll go through the code line by line to explain how I have solved this. So firstly, we are starting over here with n, which is the board size, so n times n, and then we have the directions list, which is right, down, up, and left pairs. So we are just defining them once, and then I have DFS. So over here I'm checking that what are the three stop conditions. So if it goes off the board, so any of the four bound checks, or if the cell is not a 1, which covers both 0 and cells already marked 2. And this last part is what prevents the infinite recursion. So once a cell becomes 2, revisiting it hits 1, and then it will just return immediately. Then over here, these are two jobs and two lines. So firstly, marking the cell 2 means that the first island is visited, and then appending it to queue because you're loading the BFS queue while discovering the island. So when phase 2 starts, the bottom one, I'll go through it, every cell is already a BFS source, and that's why it becomes a multi-source BFS. Now for DI and DJ in directions, we are recursing into all four neighbors, and then together this floods outwards until the entire connected island is marked and then on-queued. Now over here, I'm finding where to start DFS. So firstly, we are scanning the grid top left to bottom right. So top left to bottom right. So then we call DFS on it, and then we have a found flag, and then for the found flag we have two break conditions. Now this is very important because without stopping, the scan would later reach the second island's cells, which will still be 1, and then DFS them too. That will then merge both islands into 2, the number 2, and it will just break everything. So that's why we have a flag which is found, and that's why we have the break condition. Now is the phase 2, which is the BFS, which is expanding through water. So the steps counts how many water cells we have flipped so far, that is the current bridge length, and then the loop runs while there's a frontier to expand. And now this is our level by level BFS. So we are gonna start with a while loop that goes through our queue, and then we are gonna pop by whatever is on the top of the queue, that is pop left, and then we will go through the directions, and then what we popped we are gonna add into a direction to find the neighbor. This is the check, which is the bound check, and then we are going to check if this neighbor that we created, NI and NJ, if this is 1. Now at this point, this can only be the second island because every first island was repainted 2, like the number 2, before this BFS even began. So the first time we touch this this one cell, it means that it is guaranteed to be via the water cells, so we just instantly return steps. Also, we are going to return steps and not steps plus 1, because the cell that we are touching is land. It does not need any flipping. Only the water that we crossed needs flipping, so just make sure you return steps. And then else if it's a 0, so water, if it's water we claim it, which means we mark it as 2, so no other path re-explores it. So this 2 is our visited set. I'm just marking it as 2 over here, and then we are going to append it to our queue because it's ours. And at the end, not outside but within your while loop, at end of your for loop, you're going to increase the steps by 1, which means after a whole ring is processed without touching the second island, the bridge will grow by 1, and at the end we are returning steps.